You've seen the headlines, right? AI is coming to write all our software. But what's the real story behind the hype? Well, in this explainer, we're going to unpack the whole world of AI software engineers, what they are, how they actually work, and are they really ready to take over for human coders?
The hype really kicked into high gear in early 2024. You had tools like Devin being advertised as the world's first AI software engineer. And the promise was huge, an AI that could supposedly handle entire development projects all on its own. We're talking planning, coding, even debugging. This isn't just your regular code completion anymore. This was pitched as the whole job, right in a box.
So it just begs the question, doesn't it? Are these AIs actually ready for a real job? Or is this all just really good marketing? To figure that out, we got to look under the hood. All right, to really get what's going on with these new tools, you have to understand the engine that's powering them. This isn't about simple code suggestions anymore. Nope, we have officially entered the era of AI agents.
So, what in the world is an LLM-based agent? Think of it this way. If a code completion tool is like a calculator, then an agent, well, it's like a financial analyst. It uses a large language model as its brain to not just write some code, but to actually plan, use other tools, test its own work, and even learn from its mistakes all on its own. It's managing the entire workflow.
And here's where it gets interesting. These agents are being set up in two totally different ways. First, you've got your single agent system. Just picture one master AI, kind of like a lone genius, trying to do absolutely everything. But then you have the multi-agent system, which it takes a completely different approach. And this multi-agent idea is being taken to its logical extreme. I mean, systems like MetaGPT are literally creating a virtual software company. You'll have one AI acting as the project manager, another one as the programmer, and a third as the QA tester. They all work together to tackle projects that a single agent just couldn't handle alone. It's a really fascinating shift, right? From a lone AI coder to an entire AI development team.
Okay, so we have these powerful AI agents, but how do we actually know if the code they're writing is any good? Well, that brings us to the ultimate coding test. And this is a much harder problem than it sounds. I mean, code can look perfectly fine. It can compile with no errors, but it could still be slow, insecure, or just flat out wrong. So just like with human programmers, we need some really tough ways to measure the quality.
To do that, researchers have developed these specialized benchmarks. You've got Human Eval, for instance, which uses brand new handwritten problems to make sure the AI is actually reasoning, not just remembering something it's seen before. Then there's NBPP, which tests the fundamentals. But the real monster is something like SWE Bench, which just throws real, messy issues from actual GitHub projects at the AI to see how it holds up in the real world.
Now, the key metric they use across all these tests is something called pass at K. It sounds a little technical, but the idea is actually pretty simple. You ask the AI to generate, let's say, 100 different solutions for one problem. That's your K. If just one of those 100 attempts passes all the automated tests, the AI gets a win for that problem. It's really a measure of the AI's ability to eventually stumble upon a correct answer.
And if you look at this chart here from the original paper on a model called Codex, you can see a really clear trend. As the AI models get bigger, meaning they have more parameters, their success rate just goes up. So yeah, bigger models are generally better coders. But, and this is a big but, take a close look at that vertical axis. Even the absolute best models are nowhere near a 100% pass rate. And that tells us there's still a long, long way to go.
And that brings us to the reality check. Because for all their impressive skills, these AI agents have some pretty serious flaws. Let's take a look at the cracks in the code.
And this is a huge one. A recent study looked at over 100 top AI models and found that nearly half of them produced code with serious security vulnerabilities. The AI might write code super fast, but that speed means absolutely nothing if it's also building backdoors right into your application.
So what's happening here? Why are these incredibly sophisticated models making such basic and sometimes really dangerous mistakes? Well, it turns out there are a few core issues at play.
So why do these AIs get things right when they do? A recent study broke it down, and the results are, well, they're pretty revealing. Task difficulty is obviously a big factor, but look at this. Over a third of an AI's success comes from something called solution leakage. That's a fancy way of saying the model has probably seen the exact problem and its answer in its training data. So in a lot of cases, it's not actually reasoning, it's just remembering.
This leads to some new and, frankly, kind of terrifying security risks. One of them is called slopsquatting. See, because LLMs sometimes just make up or hallucinate names for software packages that don't exist, attackers can get ahead of them. They create malicious packages with those exact made-up names. Then, a developer uses the AI-generated code, runs an install command, and boom, they've just installed malware without even knowing it.
This chart shows another core problem, what's called alignment failure. That green line? That's the AI's performance when you show it correct code examples. But look at the orange line. That's what happens when you show it examples that have subtle bugs in them. Performance just tanks. The AI doesn't fix the errors, it copies them. Its main goal is to mimic the patterns it sees, even when those patterns are wrong.
So if AI isn't ready to be a fully autonomous engineer, what's the path forward? Well, the answer seems to be all about partnership, about keeping a human in the loop.
And this means we need a total shift in how we think about this. The goal isn't to replace developers, it's to augment them. You have to think of AI as a powerful tool to handle all the tedious grunt work, which then frees up human developers for the important stuff, like creative problem solving and critical oversight.
And building these collaborative tools the right way really comes down to a few key principles. Everything, and I mean everything, centers on keeping the human user in control and making the AI's process totally transparent. You have to design for failure. You have to plan for when the AI is going to make mistakes. And most importantly, you have to build in simple ways for the user to give feedback and steer the AI back on the right course.
This quote just absolutely nails it. The best AI tool isn't the one that just spits out a wall of code. It's the one that makes the human user feel smarter, more capable. It turns that potential flood of AI nonsense into a guided, interactive experience.
And this leaves us with one final big thought. As these tools get more and more integrated into how we work, the most valuable skill in software development might change completely. It might not be the ability to write perfect code line by line anymore, but the ability to explain a problem clearly, to ask the right questions, and to critically judge the answers an AI gives you. So the real question is, are we ready to make that shift?